Okay, year 11. Today's lesson, we're going to talk about our FA2. What's it going to look like? All right, so your task sheet, I'm just on your OneNote right now. Under FA2, it's the first tab. Your task sheet is on here as well as an exemplar. The exemplar is not exactly how I like for you to do the report, but please use it as ideas for phrasing and ideas for looking for limitations and reliability, validity, that sort of thing. Use it for ideas, but don't worry if yours doesn't look exactly the same. Okay? So, task sheet's there, but what I've done is made a more detailed scaffold for you. Alright? So, you need a title, preferably listing your variables. So if I was doing my possums, again using that possum example, I could look at abundance of possums in different light conditions. Okay? So see how I've used my two variables in the title? It's really good to make it really clear what you're actually doing your research on. Next is your rationale. We're quite good at rationales because we did it in year 10. But start with broad topics, and you can see how I sort of narrow it down. Your rationale is like a justification for your research question. So you need to include important definitions, but it's not just listing definitions. It's saying also what specific example you're looking at and why it's important. Why should we research this? Why should we care? Okay? Narrow it right down to your ideal conditions, and then talk about specifically your condition that you're looking at, say temperature or whatever. Okay, and then that should justify your research question. Your research question, to get full marks for your research question, to get full marks for your rationale, it needs to be, I've sort of put it in italics here, considered rationale for the experiment. So does it logically lead from a broad topic to a specific question? I don't want a big essay with lots and lots of information. I just want you to tell me what's an enzyme. Okay? What factors generally affect enzyme reaction rates? Okay, what they do. What enzyme, and you can use, for example, lipase is an enzyme used in blah, 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 and it is affected by blah, 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 blah. You know, the temperature in blah, 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 blah is blah, 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 therefore it's ideal, blah, 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 blah. Therefore, the following research question was developed. Boom. Okay? It should be like half a page of work. All right. Research question. Specific and relevant. So, relevant. Is it a yes or no question? Has to be yes or no. Does this affect this? Is there a difference between this? I can answer it with a yes or a no. I'm not gonna, but I can answer it with a yes or a no. I've given you some starters. Is there a relationship? Is there a difference? Does this increase this? Okay, and I've also told you what type of data analysis you're going to do. Are you going to do a regression and compare an R-squared value? Or are you going to do t-tests? Okay, one-tailed t-tests if you know what's going to happen. However, because it decreases and increases the rate we're expecting, increases and decreases the rate, decreases, increases the time. Remember, rate and time are inverse. So if you have a rate, for example, if I do a rate, you know that it looks like, I'm just going to use my finger because my pen's not here for some reason. If I do a rate, I'm just going to scribble on this one. Your graph looks like, are you going to let me draw? I'll love a pen, thank you. Thank you, random unidentified student. The rate, it looks like this, and it has an ideal for the rate. Yeah? Speed of reaction or rate. Now, the faster the rate, the less time it takes. So your time graph will look like this. Right? Because the faster the reaction, it takes less time. Think about runners. The faster the runner, the less time it takes for them to run. So yours is going to be inverse, your graph. Because we're not doing rate, we're doing time. In fact, I think I wrote that on the thing. If I go back here, make sure you include your independent and dependent variables, so make it relevant. And we are not recording rate, we are recording reaction time. Got it? So I don't want to see, is there a difference between the reaction rate of this and this? That's not relevant. We're not measuring it. Okay? Specific. That is the next level up from just relevant, is specific for full marks on your research question. You need to be specific about the concentrations or the temperatures or whatever. For both variables. Include everything. Make it wordy. Okay? It can have commas in it. It can have brackets in it. In fact, I like it when you put in brackets, like, you know, the variable of light for my one. What is there a difference between possum abundance and the, I don't know, light treatments in brackets? What was it? Like urban, no light, whatever it is. So I put the variables. Oh my gosh, I stuffed that one up, didn't I? And it's on record. There you go. But you know what I mean with the possums, like the 3 different light treatments, I'd list them in brackets. Okay? Here's an example of from the exemplar. All right, does it increase it? And then put it in some more detail over a 168-hour fixed growth period, blah, blah, blah. I think they could even do a little bit more, like grey water versus a control or versus distilled water or whatever it is. Tap water, I think they actually did. Okay, so they could put a little bit more detail to make it more specific. All right, so that's your research question. All good? Cool. OG experiment. So under research question, just do the title and you just literally write the research question. That's it. Then under original experiment, you literally just state one sentence. And original experiment was modified to, or was refined and extended or whatever, to investigate the specific research question. Okay? Then you slap in your reference. Smack bang APA reference. Okay? And you can also refer to your appendix. In your appendix, you can include a copy of your research question right down the bottom. Appendix, original experiment. Sorry, I said research question. I mean original experiment, okay? So you can get all that detail from either your book or from my original. Oh, look at her. Hello. She looks great. She looks great. I'll put it up here. It's actually page 200 of your book. Okay, so you can reference just your normal book. Right, back to work. All right, and then you just give me a brief summary. So what did we actually do? We were looking, is there a difference between if it sets or doesn't set? We weren't really measuring anything else, were we? We weren't measuring time or measuring anything, so that's something we changed. And I want you to put that in your modifications. So jump down to modifications. All right. You need to have sufficient relevant data. Include, we increase the number of trials from 1 trial to 3 or 5. Yeah. So that would increase our accuracy and precision. Justify that. And then we also extended it. We chose new variables. Some of us stuck with temperature, some of us chose new variables. Some of us chose new enzymes. Well, actually, all of us chose new enzymes. Okay? And we timed it as well, didn't we? Okay? So we didn't say, does it react yes or no, which we could have done. We timed it. Why did we time it? So not only does it react, but which one reacts in a shorter amount of time. So we're indirectly measuring the rate. Indirectly measuring the rate. Say it with me. Indirectly measuring the rate. I want you to remember that. I would write it down. Because one of your suggested improvements for later on could be to directly measure the rate somehow. Calculate the number of moles, calculate how much it reacted over time, you know, something like that. Do a bit of research on how you could do that. Okay? Safety and ethical considerations. You need to list the major safety considerations. That indicator would be the major one. I will post my risk assessment for you to have a look at, copy and paste the relevant parts onto your risk assessment, okay? You need to make ethical considerations as well. Ethical considerations as well. So by ethical considerations, we didn't use any living organisms, but if we were, say, doing an experiment on animals or plants or observing them, we need to consider ethics about doing that because they're living things, but also the ethics of our cleanup and disposal. How does it affect the environment? Right. So ethical disposal of our wastes. Alright, so you can say there was minimal ethical considerations, however, careful disposal of harmful chemicals, you know, the lab techs helped us out with that. Yeah, something like that. Link to your risk assess in the appendix. If we have enough time this lesson, I'll show you how to do a risk assess. If we don't, you can use mine and I will catch up next time. Process data. Now I'm going to just, thank you, run through this and double check I got it right. So, first off, these are formatting. For your formatting, I don't want to have to say this ever again, because even my year 12 stuffed this up and I've said it a million times, so I want to say it once to you. Tables are labelled on the top of the table by saying table 1 and then a brief description. Figures are labelled at the bottom, so graphs and stuff labelled at the bottom. Okay? Easy? You need to put a brief description of what you did. So, alright, the data was processed as using Excel, ToolPak, whatever it is, to calculate the mean, standard error, standard deviation, and then a regression was done. Something like that. Brief description. Alright, you need a table. Okay? You also, sorry, I'm getting distracted. There's something going on outside, guys. Ooh, drama. For the people at home. Alright, so I also need to have put in table of your data result, descriptive statistics here. A graph, bar graph, error, standard error bars. So both of them need to include this. Okay? And then if you're doing a difference, you're doing a t-test as well. Or if you're doing a relationship, you do a regression. So both will have that summary data table, yeah, with just your mean, just your standard error, and your, what else do we do? Standard deviation. You could also add in your number of trials if you want, that's fine. All your raw data will be at the end, okay? Then you need to you have to do a bar graph for both with the standard error bars, and then you do your t-test or your regression. Okay?
So regression,
scatter plot for regression, yes. T-test, you don't need to do a second graph. You just look at your bar graph. But t-test, if you have more than 2 variables, you're going to have to do t-test between all the variables. Sorry, if you have more than 2 dependent groups, yeah, more than 2 groups, you have to do t-test on between groups. So you could do between group 1 and 2, between group 1 and 3, and then you do 2 and 3. I can help you with that, don't worry. Interpretation is, now, this is where everyone stuffs it up. Interpretation is what does the data tell you? Analysis is link it back to your research question. So, in interpretation, you're literally saying, what's the pattern? What's the trends? What's the outliers? What's the uncertainty? What's the statistical significance? Is it significant or not? Analysis is, this suggests that there is a relationship between blah, 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 and blah, blah, blah. The positive slope indicates that as this increases, it increases. That's where you actually talk about what does it mean. These can be combined into a paragraph for each section, or you can do them separately. I prefer to combine them all. Personal preference, because as you state, like, oh, it's statistically significant. This means that. You know, it flows really nicely. Some people do them separately, whatever. Not going to get marked down at all. Okay? Almost there. I will go through, now, up to here, I'm quite confident you can do over the holidays. You don't have to, but up to here, I'm quite confident to let you run with it. The next section, I would hold back on, if I were you. Next section, limitations of the evidence. How the data can be applied is a limitation. So we're doing it under set conditions, it's not actually in the real life situations, so there's lots of limitations. Also, you talk about your reliability and uncertainty, okay? Specifically sample size. With things affecting reliability, it's a source of error. So you've got to talk about the precision of the equipment used. All right? We had 5 mil Saccharopora with each mil indicated, so it's got a plus and minus precision of 0.5 mil. I will talk you through this later when we get up to it. I want you to do the first half first. Anything affecting the validity, okay? Anything that affects how this data can be applied to the research question. So for example, you know, using a color change to indicate that it's actually reacted. It's hard to know if there's still reaction going on just using our eyes. Okay, stuff like that. Improvements is so easy to do. Once you've got good sources of error and sources of limitations, every single one is just how you fix it, how you fix it, how you fix it, how you fix it. Okay? So, and then what I would do is copy all this, paste it under there, and then rewrite it as a solution, and then delete it all. All the other ones. Okay? Extensions, redirect, what else could you investigate? Different enzymes, different blah, 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 and justify why you would do that. Extension. What could you investigate further with your experiment? I feel like the temperature ones, we could have narrowed down and had closer temperatures to around its ideal temp. Yeah? To get a more accurate reading. Is it actually just bang on 40 or is it slightly below, slightly above? Conclusion. You restate your research question. Do not write it as a question anymore. Okay? Don't write, does it do it? Yes, it does. That is silly. You say, there is a statistically significant difference between this and this. Or you say, there is not a statistically significant difference between this and this. Or there is a relationship between blah, blah, blah. Or there is not a relationship. You can say, according to the data, blah, 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 blah. Okay? Then you add any qualifier, major limitation, or any main improvement. So you just do 1 or 2 sentences on saying, like, say, you could say, there is a statistical difference between this. However, this wasn't investigated under these conditions, or these errors were made, therefore more research is needed. Something like that, like a qualifier. Okay, saying it's not perfect. Or there isn't a difference, however, it was expected that there should be, therefore more research is required. With the fixed errors or something like that, okay? References, 3 to 5. Most of your references will be, you'll have your original experiment, yep, and you'll have 4 more for your background, oh, not your background, your rationale, yeah? Okay, and then you've got your appendix with your raw data and everything. A real Gucci. So, over the holidays, what I want you to do, if you're going to work on it over the holidays, which I highly suggest you do, because I'll be up to limitations and stuff with you next, is title, bit of rationale, research question, original experiment, how you modified it. If you're not sure which one it fits under, just put it down somewhere and I'll sorted out for you. Safety and ethical, you can slap your data in there, okay? And you can start on your interpretation. I don't expect this to be absolutely perfect over the holidays, I just expect you to have an attempt at all of those. Leave the evaluation until after the holidays. Okay. Now, what do you want to do now? Do you want to do a risk assess now? Or do you want help with your data? Oh, pause the recording.